Hi folks, this is number 12 on page 481. So what they want us to do is they want us to find the equation of a line, and this line has the same x and z intercepts as this given plane. Okay, so to find the equation of a line in 3D, we need a point and we need a direction vector. Okay, so let's start by finding a couple of points because we can find the x and z intercepts of this plane. Okay, so to find the x-intercept, we just set y and z to be equal to 0. So we've got 2x equals -7, bringing that 7 to the other side. So x is equal to -7/2. So our x-intercept, and I'll call that point A, is -7/2, 0, 0. Okay, and now we'll do the same thing for the z-intercept. You make x and y equal to 0. So we have -z plus 7 equals 0, so z is equal to 7. So our second point on this line is 0, 0, 7. Okay, but now that we have these 2 points on the line, we can easily determine an equation. Okay, so first thing, so we have a point. Let's just find a direction vector. Okay, so here I'll take AB to use as my direction vector, or at least something parallel to that. So here we've got 0 minus 7/2, so we have 7/2. 0 minus 0 is 0, and 7 minus 0 is 7. Okay, so here I can use as my direction vector, well, I'm going to simplify this a little. So if I multiply by 2, what do I get? I get 7, 0, 14. But in fact, I should also now be dividing by 7. So I could have actually multiplied this by 2/7 to get an even simpler one here. So what I'll use as my direction vector, okay, 7, 0, 14 is fine, but I might as well use 1, 0, 2. Okay, if at all possible, try to use a vector in simplest form. Okay, but now we have enough information to write the equation of the line. So the equation of the line is a point. So I'll pick 0, 0, 7, 0, 0, 7, plus some parameter times my direction vector 1, 0, 2. And of course, t can be any real number. Okay, so now we'll write in parametric form. So here x is equal to 0 plus t, so just t. Y is equal to, well, y is just always equal to 0. And then z is equal to 7 plus 2t. Okay, and now if I want to write it in symmetric form, again, t, all real numbers. Remember, symmetric form is like we're just solving for t. So here, what's our point? So it's x minus 0, so it's x over my x component of my direction vector, which is just 1. Okay, now here the z component, sorry, the y component of my direction vector is 0, so I can't include that. I can't have 0 in the denominator. So what I'll have here is, let me write out the z. So z is going to be z minus 7, z minus the x component of the point, over 2, which is the z component of the direction vector, and then I just specify that y is always equal to 0. And there you go. There we have it in symmetric form. Okay, so that's, let's just do a quick recap. Again, how to find intercepts, set the 2 other variables to 0, and then once we got those 2 points on the line, we just produce the vector between them to determine our direction vector. Okay, that's it for this one.